Okay, so you've got to picture this. It's the early 2000s, and Google is, well, they're basically drowning in data. They're trying to index the entire web, and the amount of information coming in is just threatening to break everything they've built. So what was their solution? A database they called Bigtable. And the paper they wrote about it? Oh man, it literally changed how the internet stores information forever. Let's dive in. So let's really set the scene here. We're talking early 2000s. Google is way more than just a search engine at this point, right? They're launching Google Earth, Google Analytics, and the data is just exploding. I mean, we're talking about a scale that nobody had ever seen before. This wasn't just a big data problem. No, this was a petabyte problem, a completely different beast. And just to give you a sense of that scale, look at this, 200 terabytes. And that was for just one single table for the raw click data in Google Analytics, just one. They had more than 60 other projects just like it, each with its own absolutely massive data set. It was a completely insane amount of information to try and manage, let alone search and analyze.
So here's the problem, right? Your standard off-the-shelf database from back then, the typical SQL databases, they would have just crumpled under this kind of load. They simply were not built for this. So put yourself in their shoes. You're a Google engineer. What do? Do you try to build the world's biggest, most expensive super server? Or do you throw out the rulebook and rethink the entire problem from scratch?
Well, you guessed it. They chose to rethink everything. Instead of trying to hammer a square peg into a round hole, they built something completely new. A distributed storage system designed from the very beginning to run on thousands of cheap, everyday servers. And they gave it a simple, powerful name, Bigtable. Okay, so this is the official definition from the paper, and I know it's a total mouthful. A sparse, distributed, persistent, multidimensional, sorted map. It sounds super academic, right? But trust me, every single one of those words is critical. Sparse means it handles data with lots of empty spots really well, kind of like a giant spreadsheet where most cells are blank. Distributed just means it runs on tons of machines at once. We're going to break all this down because it really gets to the heart of what makes Bigtable so different from any database that came before it.
All right, so let's make this a little more concrete. This comparison really shows you how Bigtable just threw out the old rulebook. A normal SQL database, it has a super rigid schema. You have to define all your columns ahead of time and you're stuck with them. Bigtable, totally flexible. You can add new columns on the fly whenever you want. But the real game changer, the absolute key, is scalability. Traditional databases scale vertically. That means when you need more power, you have to buy a bigger, beefier, way more expensive server. Bigtable scales horizontally. You just add more cheap, commodity servers to the pile. And that right there was the secret sauce for handling Google's insane growth.
Okay, so let's dive into that core idea, that whole multi-dimensional sorted map thing. How in the world does that actually work? Well, first, you've got to forget everything you know about normal tables with their neat, fixed rows and columns. For Bigtable, we need to start thinking in 3 dimensions. This right here is the heart of it all. At its core, Bigtable is basically just a giant, glorified lookup table. Think of it like a coordinate system for your data. Every single piece of data is indexed by a 3-part key, a row, a column, and a time. You give Bigtable those 3 coordinates, and boom, it hands you back the data. It's such a simple concept, but it's also incredibly powerful. It's the foundation for everything else. Okay, now check this out. This is the web table example straight from the paper, and it shows how this works in the real world. So the row key here is the website URL. The contents column, that holds the actual HTML of the web page. And notice how there are multiple versions. Each one has a different timestamp, T3, T5, T6. That's versioning, baked right into the system. And then look over at the anchor column family. That's tracking all the other websites that are linking to CNN. This model is just so flexible for storing this kind of messy, semi-structured data. And here is the big aha moment. This is such a simple but absolutely genius design choice. Instead of using a normal URL like maps.google.com as the row key, they flipped it. It becomes com.google.maps. Now, why on earth would they do that? Because Bigtable keeps all of its rows sorted alphabetically. So by reversing the domain, all the pages from the same site, like com.google.maps, com.google.news, com.google.mail, they all end up physically stored right next to each other. This makes running any kind of analysis on a whole domain unbelievably fast. So clever. So let's do a quick recap of the main building blocks. You've got your rows sorted alphabetically. You've got your column families to group similar data together. And you've got timestamps, which means every single cell is versioned. But the final piece of the puzzle, the thing that makes it all scale, is something called tablets. Bigtable automatically chops up these massive tables into smaller 100 to 200 megabyte chunks, and it scatters those tablets across thousands of servers. That's the secret to its mind-boggling scale.
Now, it's super important to remember, Bigtable wasn't just some academic research project. No way. This thing was immediately thrown into the fire and put to work as the foundational backbone for some of Google's absolute biggest products. It was battle-tested at a scale the world had literally never seen before.
I mean, just think about the who's who of Google products at the time. Google Search, Google Analytics, Google Maps, Google Earth, Personalized Search, even Orchid. All of them, every single one, needed a way to store and retrieve insane amounts of data, super fast and super reliably. And Bigtable was the answer. It truly became the bedrock that so much of modern Google was built on top of.
And this chart from the paper, wow, it just perfectly shows the magic of that horizontal scaling we talked about. Look, with one server, you get about 8,000 writes a second. Pretty good. But watch what happens as you just add more cheap machines. The performance scales almost perfectly in a straight line. By the time you get to 500 servers, you're handling over 1 million writes every single second. Need more power? The answer is simple, just add more servers.
And that wasn't some theoretical number from a lab test. Nope. By 2006, in the real world, busy Bigtable clusters were handling over 1.2 million requests every single second. This thing wasn't just a clever design on a whiteboard. It was an absolute workhorse, built to take the crushing, relentless load from Google's users all over the planet. So the story doesn't end there. The final chapter isn't just about what Bigtable did inside Google's walls. It's about what happened when Google decided to tell the rest of the world how they did it. Because Bigtable's influence was about to explode far, far beyond their own data centers. This timeline really lays it all out, so by 2005, Bigtable is already running the show inside Google. But the real turning point, the moment everything changed, was in 2006, when they published the paper. For developers everywhere else, it was like a blueprint just fell out of the sky. The ideas in that paper directly kicked off an entire generation of new databases, what we now call the NoSQL movement. Projects like Apache HBase and Cassandra basically took the core concepts from Bigtable and made them available for everyone to use. So after all of that, what was the biggest lesson the creators themselves took away from it? You might think it was some complicated algorithm, but it wasn't. It was this simple, profound truth. The most important lesson we learned is the value of simple designs. Think about that. They were staring down one of the most complex data problems in history, and the answer wasn't more complexity. It was a simple, elegant design that was powerful enough to solve. And that really brings us right up to today. I mean, the amount of data in the world is only getting bigger, faster, and way more complex. So the question I want to leave you with is this. In our world of AI, the Internet of Things, and data sets we can barely even imagine, how are those core, simple ideas from Bigtable, scaling out, not up, being flexible with your data, and valuing simple designs, how are they going to continue to shape the tools we build to make sense of it?